in the SBIST, Shargokananda Institute of Science and Technology. Now, today we are going to discuss Lagrange interpolation formula. At first, we know that what is the Lagrange interpolation formula. Lagrange interpolation formula, in the previous class we discussed Newton's forward formula. Newton's forward formula, let y equal to fx be the continuously differentiable function in the closed interval AB, and Newton's forward, Newton's backward is the mass necessarily equispaced. But here in the Lagrange's interpolation formula, it is not necessarily equispaced. It is also applied for the unequispaced points. So here, let us take an polynomial, and the polynomial is denoted by ln x. So ln x is equal to, we denote fx, and fx is equal to yix. So here, at first we take our polynomial ln x is equals to this type of x minus x0, x minus x1, x minus x2 up to x minus xn. That means nth order polynomial. Here our points are not necessarily equispaced. At first we tell that. So here that ln x is the interpolation, Lagrange's interpolation, we learn that, and here some constant. What is the constants? Constants are a0, a1, a2 up to a. Here ln x is equals to, we write x, at first we take x equal to x0. So our polynomial is y0. So x minus x1, x minus x2 times x minus xn plus times a0 plus x minus x0, x minus x2 times x minus xn times a1. This process is continuing up to nth order. Here our Lagrange's interpolation formula becomes ln x is equals to or a0, a1, we substitute this formula and formula becomes x minus x1, x minus x2, x minus xn. Here this first our points x0, y0, x1, y1, x2, y2, x3, y3. Here 3 points are given, less or equal to 3 polynomial of degree. So here we apply nth formula. So here first x0, x minus x1, x0 minus x2 times x0 minus xn times y0. At first y0, here minus 1. Then plus also these processes are continuing. So our formula is Lagrange's, is called is Lagrange's interpolation formula. Lagrange's interpolation formula. We establish that. Now we take an example. This is the example, and here we apply how to Lagrange's interpolation formula. We become a polynomial of degree of 3 lesser equal to 3 as polynomial we are become. So using Lagrange's interpolation formula, ln x equals to x minus x0. So here x0, y0, x1, y1. These are the points, and not necessarily equispaced. At first we say x2, y2 and x3, y3. So these are 3 points, and 3 points we substitute here Lagrange's interpolation formula, and this x minus x0. That means x minus x1 at first. So we omit x0 points, and x minus x0, x minus 1, x minus 2. Then divided, we substitute x points are, we substitute x0. x0 points, what is the x0? Here minus 1. So minus 1 minus 0, minus 1 minus 1, minus 1 minus 2 into multiplied by y0. Because our Lagrange's interpolation formula times y0. So y0 is given 1. Then applying next part x minus x plus 1, x plus 1. That means x minus 1, x1 omit here. So x plus 1, x minus 1, x minus 2, and divided by x1 we substitute 0 plus 1, 0 minus 1, 0 minus 2 times 1. That means y1. So here y1 plus up to second part, third part. Third part is x plus 1, x minus 0, x minus 2. Here omit x2 portion. So x2 portion we divided, here putting 1 plus 1, 1 minus 0, 1 minus 2 times as usual y2 plus last portion is x plus 1, x minus 0, x minus 1 and substitute x3 equal to 2 here, 2 plus 1, 2 minus 0, 2 minus 1 into times y3. y3 is given minus 3 and this is the required solving, we get required interpolation polynomial. Lagrange's interpolation polynomial. Interpolation polynomial. This is polynomial, this is degree lesser equal to 3. So this process we find the polynomial of degree lesser equal to 3 or lesser equal to 4, whatever we given in question. How to find? We apply Lagrange's interpolation formula, and here this space are not necessarily equispaced. So our result is becomes. So this is the required answer. Thank you everyone.